So, as we have covered last time virtual memory concepts, and we had seen the role play of data structure like mapping table, page table, pages, frames, blocks, and we also remember that virtual memory is translation actually. The virtual memory concept is translation of logical address to physical address. In continuation of that, from Unit 4 of the subject Computer Organization, we will consider today a very, very small topic called as memory management requirements. These are few of the keywords I just jotted down for that. This is our topic, memory management requirements, and this is from Unit 4 of Computer Organization subject. And in Hamachar textbook, it is given on chapter number 5. Now, coming to this topic, memory management requirements, it came immediately after virtual memories. So, there is a linkage between this virtual memory topic and memory management requirements. Let us try to connect these dots. What is virtual memory? Here, when we implement our virtual memory concept, a program which needs to be executed by the CPU has to be brought in the main memory. And what the concept says, the entire program will not be brought into the main memory. It means what? Part of the program will be brought from secondary memory to main memory for execution of the program. Which part of the program will be brought? At the current instant, whatever active part of the program needs to be executed, that will be brought. Now, to implement this concept, there are specific management routine requirements. So, what are the specific management routine requirements? Here comes the role play of operating system. Here comes the role play of operating system because this entire virtual memory concept has to be implemented through operating system. Has to be implemented through operating system. So what will happen here is the virtual address space. The virtual address space will be divided into two parts: a system space and a user space. So the system space will have all the operating system routines required for implementation of this virtual memory concept, while the user space will have the application programs. Okay, so there can be multiple application programs active at the same time, so you can treat your user space similarly. How? You'll be having this data structure called as page table, so there will be separate page table for each application program. This is the concept. Now you also remember something called as MMU. So if you don't remember it, let us just try to get it. Give me a minute. Let me check if this was discussed for performance consideration. Let me check where is that. Yeah, this was diagram we were referring to understand virtual memory, and we had said that MMU is the unit, memory management unit, which will be converting, translating the virtual address to physical address. This entire journey we remember. So the same MMU we are referring. And the MMU, we know that it is using the page tables. MMU is using the page tables. So, and MMU is using a specific data structure called as page table base register for translation. This is the page table base register. This will be used for translation. Now, what the operating system can do is the content of this page table based register can be changed, and what that change indicates. So, as there are multiple application programs running, and for each program there may be separate space, separate page. So, OS can make changes here in the page table based register to accommodate different pages. Okay, thus allowing multiple application programs to be run at the same time. So here what is happening then, all the application programs, user application programs are sharing the physical memory. It means what? Many of the application programs may be referring same address location, same addresses. So here the entries may be duplicated. Here the entries may be duplicated. So this is one kind of management routine requirements, memory management routine requirements. The other requirement is protection. What is the need of the protection here? The need of the protection is multiple application programs are running. So they may be clashing for the resources, they may be clashing for the same address space, they may clash for the same data. It may happen. So to achieve protection and to avoid all these conflicts, what can be done is CPU can be kept in a supervisory mode, having more power, uh, more features, and the other unit for running the application program can be kept in the user mode. Can be kept in the user mode, where your user programs will be doing the routine executions, but they'll not be able to execute the privileged instructions. Why they will not be able to execute the privilege instructions? Because only supervisory mode can execute the privilege instructions. Can execute. For example, page table base register entries need to be changed. So no, anybody cannot change. So supervisory mode, if it is having a supervisory mode, then only it can change. So other kind of protection is read and write access protection modes. Uh, this is a small topic called as memory management requirements covering these aspects. Hope you could connect with this.